Hello and welcome to this pre-lab video. In this lab, we will be looking at Le Chatelier's principle. And this is a very straightforward lab. It's very simple. And what we're going to be doing is we want to kind of explore Le Chatelier's principle. And we're going to be using a series of, well, for the most part, complexes, but also some acid-base chemistry to kind of show how equilibrium systems can be manipulated or tipped in one direction or another. And we're going to use some reactions that are very visual to help you to see this kind of transition and change through the use of colors. So the experiment itself, there are 4 reactions that you're going to be looking at. And what you're going to need to do in those reactions is you are going to be recording observations related to what the equilibrium system looks like right now. So if you were to pick up this bottle, what would the equilibrium system look like at that moment? Identifying what color is responsible for, or excuse me, what chemical species is responsible for that color, and then how that color changes as a result of some different things that you're going to do to it. Each time along the way, you're going to explain what it is that you did, what it is that you saw, according to Le Chatelier's principle. Now, the thing that you need to know about this particular experiment is obviously we are picking things that are going to work and are going to manipulate the equilibrium system. So you should expect to see changes in each of these reactions. And if you don't see those changes, that's when you need to get my attention in the lab and let me know, hey, this isn't working the way that it should. And we can work together to try to figure out why it's not working the way that it should. But what you're going to do is you can see you're going to be collecting observational data and explanations for each of the 4 procedures. And that's it as far as data collection is concerned. Now, there are some post-lab questions here, in particular asking you to look at one of the systems that you looked at, the cobalt system, and determine whether it's exothermic or endothermic based upon some observations that are written in there. So as an experiment, this is a very straightforward experiment. So let's look at the 4 systems themselves, just to kind of give us a little bit of context. So the first system that we're going to look at is the chromate versus dichromate system. Now, chromate on its own is a yellow color. You've seen it when we were doing lead testing. Chromates are the ion that you use to determine the presence of lead. So we know what that looks like. It's that kind of dark straw yellow color. Dichromate, on the other hand, is a brighter orange color. And so with the equilibrium here, what we're looking for is if we increase the acidity of that reaction, increase the amount of hydrogen ion present in that solution, we should see a shift from the yellow chromate to the orange dichromate. And so that's what we're looking to observe here in this reaction overall. In the second reaction, we are looking at the cobalt hexaaqua complex here. So this is basically what you expect to see when we dissolve cobalt in water. It's a light pink kind of color. And the transition is that in the presence of excess chlorides, that light pink cobalt turns into this kind of dark royal blue kind of cobalt chloride complex. And so we're going to see how we can manipulate that equilibrium accordingly. In the third system, we are going to be looking at this ammonia equilibrium. So we are looking at aqueous ammonia versus its ionized form. So what happens when that aqueous ammonia reacts with water in solution to make ions? This is basically the fabric of what a weak base does in solution. And so what you're going to do is we're going to use an indicator known as alizarin yellow R, and it is going to appear one color in the presence of ammonia, and it's going to appear a different color when there are higher level values, higher amounts of hydroxide present. And so we're going to manipulate this. We're going to look at, well, what happens if I add ammonium chloride? Which way is it going to go? How's that going to impact the position of the equilibrium? And then the last one here, we are looking at saturated sodium chloride. So sodium chloride we know is pretty soluble in water, but it does have a saturation limit. And when we hit that saturation limit, this equilibrium gets established where now we have this interplay between the solid being a solid and dissolving into the water and kind of going back and forth between the two states. And so what we're looking for is we are going to take this solution. And so the solution itself would be the right-hand side of this equation, where if there is no solid present, that solution is full of these ions. And we're going to push on it. So we're going to see what happens when we add hydrochloric acid and increase the concentration of the chlorides. Then we're going to, the last part here is we're going to do a thermodynamic kind of study. Determine if this is an exothermic reaction or an endothermic reaction based on how does this stuff feel when we dissolve it in water. Does it feel warm, like it's releasing energy? Or does it feel cold, like it's bringing energy in? And that kind of information, exothermic versus endothermic, can allow us to put heat on one side of the equation or the other and help us to figure out, well, how would I get more of this to dissolve? What would I be able to do if I wanted to get some of this solution to come out of the solution and to re-solidify? So the experiment itself is very straightforward. It's pretty quick hitting. And so long as you understand kind of the explanations behind it, the lab will go very, very fast. And that's important in this particular case because it'll give us time to work on other things at the end of this experiment time, should we need to, because we've got a quiz to prepare for. We've got some other things that are going along here. So that will definitely help this along. If you have any questions, feel free to ask, reach out to me. Otherwise, I'll see you next time in lab.